So alphanumerics, some punctuation characters, and white space in most dialects are simply commands that say, match this character at the next position in the string. And everything else in a regex is what we call metasyntax. So any command that isn't a command that says match this character that I am is a metasyntactic command. And in all of the dialects that we're looking at, these metasyntaxes are specified using some kind of punctuation character. Unfortunately, it's not always the same punctuation character across the dialects, and that can be kind of frustrating. So here's a little table of the various metasyntactic characters in the different dialects. You'll notice that in most of the dialects there's only a small number of them: the dot, the slash, the caret, the $sign, the star, and the opening square bracket. The editors sometimes have a few extra characters that are metasyntactic, and Perl 6 goes in a different route. Perl 6 basically says if it's not alphanumeric or underscore, then it's metasyntactic. There's no real logic or system or rationale for the selection of these as metasyntactic characters. Basically, it comes down to you just have to learn them or use some kind of a cheat sheet. And on the website, you'll find a cheat sheet that shows you all of the metasyntax in all 6 dialects that you can use to work out what's going to be straightforward and what's going to be meta. So, if I have a command that is a meta command, so it's represented by one of these metasyntactic characters, how do I convert it to the command to match that actual character? So for example, the dot character in all syntaxes is metasyntactic. How do I then match a literal dot character? And the simple answer is you just backslash it. In all of the dialects, if you put a backslash in front of one of these special characters, it stops being special. Now that actually can be a problem because it leads to kind of a plague of backslashes where you end up where you want to say something like, I want to match 4 asterisks and then a $sign and then 999.99. And the asterisk and the $sign and the dot sign are all metasyntactic, so I have to backslash them all. That can be kind of frustrating, and it can make regular expressions more difficult to read. So some dialects give you a little bit of help with that. And in particular, ERE and PCRE and Perl 6 dialects have different mechanisms that allow you to say, all right then, for a little while, turn off the special meaning of these particular characters. And in ERE and in the Perl-compatible regular expressions, the way you do that is with a \q, and then anything after the \q is no longer special until it encounters a \e, which is the end of the quoting, which is what the q means. So you can simply put the sections with special characters in these \q, \e pairs, and now they're not special anymore. And you end up with, on average, less backslashes. In Perl 6, we have a different approach. In Perl 6, the single quotes and the double quotes are actually quoting mechanisms within a regular expression. So if you want something to be treated as literal characters, you just put them in single quotes, and then there's nothing special about them. They're just matched as literal characters. And you can see here, I've just quoted the $$ and the dot, and now they'd be treated as ordinary characters to be matched literally against themselves. We've already seen some of the metasyntax that's available in regular expressions, specifically the metasyntax that's available for specifying 2 alternative paths by which the regular expression could match. That is, the vertical bar or the \/ vertical bar. And that command is simply either match what's on my left-hand side, or if that fails, match what's on my right-hand side. So because you want to do that quite frequently, there are various shorthands available for matching alternatives. And the commonest case there is the alternative you want is match an A or a B or a C at this position. And indeed, it's not likely to be A or B or C, it's likely to be A or B or C or D or E or etc., 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 or Z. And when you want to do that, when you have a set of single characters and you want to match any one of them, then the metasyntax you want is known as a character set. And a character set in almost all of the dialects is simply represented by square brackets around a list of characters. And in the Perl 6 dialects, by angle brackets and square brackets around the list of characters. And so when I write square brackets around a list of characters, I'm not saying match X and then Y and then Z. I am saying match X or Y or Z at this position. In other words, if we look at it in pseudocode, it kind of looks like this. It says, okay, get the character at the current position in the string and make sure it is an element of this set X, Y, Z. Make sure it matches one of them. And if it doesn't, start backtracking, and if it does, move ahead through the regex. So diagrammatically, as a finite state machine, that looks like this. I've got 3 different alternatives, all of which lead me to the same next state. So any of them is acceptable. But in reality, that's not what's happening in the implementation of most regex engines when you have a character set like this. In reality, what's happening is it's in fact building some internal set representation and only doing a set lookup on that once. In many implementations, the way that this works is that where it sees a character set, it actually builds a bit string. And every bit in the string represents one ASCII character. So you create a bit string of 128 bits if you're just dealing with ASCII, or 256 bits if you're dealing with Latin 1, or something even much longer if you're dealing with Unicode. And you look at each of the characters in the character set and you set the corresponding bit for that character's ASCII code. And then when it comes time to match this particular thing, you grab the character that you're interested in, the next character in the string, you get its ASCII code, you look that up in the bit string, and if that bit is set, you say, yes, we've matched. Which means that a character set like this is intrinsically more efficient than saying A or B or C, because the A or B or C might have to do 3 separate attempts to verify whether or not it's going to succeed, whereas the bit string lookup just does a single lookup. It's effectively a hashing algorithm, which reduces the linear cost of checking all the alternatives down to a constant cost of indexing into the bit string. Now, of course, as soon as this kind of shorthand was created, the next thing people wanted was shorthands for the shorthands. And the most obvious one of those is, I certainly don't want to write character sets that represent all of the available characters. I don't want to have to enumerate every possibility in a range of characters that I'm interested in, like the lowercase and the uppercase alphabetics. That would just be ridiculously tedious. So very quickly, there was introduced another metasyntax that operates inside the square bracket metasyntax, where if you put a dash between any 2 characters, that means any of the characters in this range. And effectively all it does is go and set all the bit from A through to Z, and then from capital A through to capital Z, and it simply matches on those. In Perl 6, the syntax is slightly different. You use dot dot to represent a range, because dot dot is the standard notation for a range elsewhere in Perl 6 as well. Of course, as soon as you give someone that capacity, the first thing they're going to want to do is represent all the characters that are not alphabetics. And then we're back to enumerating all of the characters that don't represent alphabetic characters, and again it's very, very tedious. In this case, it's worse than that even. It's not all the characters that aren't alphabetics, it's all the characters that aren't vowels. A, E, I, O, and U. So that, of course, is completely absurd. So there's another metasyntax as well. If you start your square bracket character set with a caret, then that flips the meaning of all the bits in the intrinsic set. In other words, it says create a bit set with A, E, I, O, and U, and then flip all the bits, which effectively creates a bit set with everything but A, E, I, O, or U. And that's why the caret was used originally in the syntax, because in the languages where this was first introduced, the caret was the bitwise complement operator. In Perl 6, we have, again, a different syntax, and that is you simply put a minus sign in front of the square brackets to say not this. The reason you do that is that in Perl 6, these kinds of character sets are in fact set operations, and that's just set difference. So give me the universal set minus these characters. And of course, even at that point, people aren't happy with the amount that they have to type. So if I wanted to say something like all of the lowercase alphabetics and all of the digits and all of the possible space characters, space and tab and whatever other space characters there might be, then I could write something like that. But most dialects give you a way of describing what you want in your character set in a more abstract kind of way, by name. And that syntax, again, varies from dialect to dialect, but in most of them, it's simply this. Within the outer set of square brackets, you can use inner sets of square brackets with colons added to them, and then you can put the name of a standard kind of POSIX character class. The lowercase letters, the digits, the space characters. And in Perl 6 it's quite similar, except that they're kind of built in, so you just say add in the lowercase ones, add in the digits, add in the space characters. Note the critical thing here is that you need double brackets to do this. A really common error with this kind of construction is to write something like this, where what you presumably wanted to achieve was a character set that represented all of the alphanumeric characters. But that's not what that regular expression is doing. That regular expression is saying, I'm making a character set where the first available character is a colon, and the second one is an A, and the third one is an L, and the fourth one is an N, etc., etc., etc. So it's more or less the equivalent of saying, match this or this or this or this or this. It kind of looks right, but you left out the extra set of square brackets. The nice thing about this is that you can use all of these features together to create quite sophisticated character sets that match a very specific set of characters. So you could say, I want to match one character. It can't be a vowel, it can't be a punctuation character, and it can't be a digit greater than 3. So you could write that like this. We start off with the square brackets, and then we say, I don't want to match A, E, I, O, or U. And I don't want to match the punctuation marker. And I don't want to match the numbers 4 through 9. And a few dialects even allow you to go further than that and use full set operations. And you can use them in most of those dialects on Unicode characters. So you could say, for example, I want to match a single character that's either a decimal digit or a lowercase hexadecimal digit, but not a vowel. So that looks more or less like this. I want to either match a digit, or I want to match a hexadecimal digit, and it has to be lowercase, but it can't be A, E, I, O, or U. And as you see, there are different syntaxes for each of those, but they all achieve more or less the same thing, which is to be very, very specific about what kind of characters we want, but quite readable in the long term. The character set syntax and set of features differs in every single regex dialect, and it really is worth learning the character set sequence for yours, because character sets are a very efficient way of selecting between possible characters. Now, as we just saw, in some dialects you can specify particular characters as named POSIX sequences. The characters that are alphanumeric, the characters that are hexadecimal digits. And generally speaking, any time that you can inject a meaningful name into a regular expression, that regular expression is going to be less terrifying to everybody else and more maintainable for you when you come back to it in 6 months' time. So naming things is one of the great keys of making regular expressions more understandable and more maintainable. So these shorthands for the common character classes, like alphas and digits and so on, actually have shorthands for their own. So at this point we're at shorthands for shorthands for shorthands. And these shorthands don't even require square brackets. Basically, they are a backslash followed by 1 or 2 letters that tell the regex engine what you want at this point. The standard ones that we use very frequently are \d to represent any kind of digit, \s to represent some kind of space character, and \w to represent some kind of identifier character, which is usually an alphanumeric or the underscore character in most dialects. And in addition to those, we also have capitalized versions of them. And in all the dialects, the capitalized version of any of these is the opposite. So \d is anything that is not a digit. \w is anything that is not an identifier character, and \S is anything that is not a space character. And generally speaking, of those capitalized ones, the \S is going to be by far the most useful to you. Because sometimes all you need to do is say, I want to match everything up to the first space character, and that's literally just \S*. We'll see what the star means a little bit later. There are more than that in some dialects. So some dialects also allow you to match only horizontal space, which is \H, or of course \H, which is not horizontal space. Likewise vertical space, likewise special Unicode characters, likewise general properties from the Unicode character set as well. In some of these dialects, you can use these \/ letters inside other character sets. So one technique that you'll see used quite frequently in regular expressions is to combine the square bracket character set with the \/ named character sets to get the effect you want with very little typing. So here, for example, is a regular expression that is going to match the very first character of an identifier. That is, an alpha character or an underscore, but not a digit. And the way that you'll often see that written is like this. Square brackets, meaning a character set, the caret at the beginning meaning not, and then the \W. The \W means not a word character. So if I'm saying not a word character, that must be a word character. But after that, I've also got the lowercase d, not a digit. So not a word character is a word character, but not a digit. The dialects that provide this also allow you to use full Unicode properties. So you could write something like this. You could say, I want the property that it is an uppercase character followed by a space character followed by not a digit character. And these, of course, would not just match ASCII uppercases and spaces and digits, but the full Unicode range of those characters as well. So if your dialect supports this, I encourage you always to use these named character sets in preference to actually enumerating the characters that you're interested in. The name makes the character set much more maintainable in 6 months or 6 weeks or even 6 days when you come back and try and understand this regular expression that you wrote. So use those wherever you can. One of the most frequently used pieces of metasyntax is the any character. So all of the commands that we've looked at so far are testing either for a specific individual character or for a specific set of characters. But sometimes when we're matching something, there are places where we actually don't care what character we're going to match as long as there is some character that's present. So for example, if we're looking through a list of credit card numbers for one that ends in 7001, then we don't really care what the other 12 digits of the credit card are as long as they're there. Likewise, if we're looking for a word that's F something something K, then those something somethings could be anything that you like. So of course, in all regex dialects, there's a syntax that says match any one character, but I don't care what character it is. And that syntax in almost all the dialects is the dot character, the period. So here, for example, we have a regex that matches typical kind of credit card number ending in 7001 and any word that is F anything anything K. And this would be a really short section and very simple to understand if that was all there is to it. But there's a problem with the dot character, and that is that the meaning of any is different in virtually every dialect. So here's a table. In some of the dialects, the simple dot means literally any character that is capable of being passed to this regular expression. In other dialects, the dot means any character except a new line. And this dichotomy comes from the early use of regular expressions in tools like awk and grep and sed, which were intrinsically line-based. And because they were intrinsically line-based, then it didn't make sense for dot to match a new line, because within these tools there were no new lines because we were operating on single lines at a time. And when these kinds of regexes started to be ported into programming environments, either editors or into programming languages, where it was possible to have strings that consisted of multiple lines with new line characters in between those lines, then everyone had to make some kind of decision about what dot was going to mean at that point, and basically everyone came up with a different decision. So in about half the modern dialects now, the dot means literally any character including new line, and in the other half it means any character except new line. And in almost all of those dialects, there is a way of getting the other alternative, whatever the other alternative happens to be. And in each of those dialects, the other alternative is always a bit more complicated and a bit uglier, because basically the dialect is guessing that what you're going to want most of the time is either any character or any character except new line. And again, there is no magic way of knowing for any given dialect which way round it is. It's just something that you have to learn, and ideally what you should do is learn both the literally any character version and the any character except new line version, and then use the one that you actually mean. Say what you mean in each case. If you really do mean any character at all, then use the syntax in your dialect that means any character at all. If you really do mean but not new lines, then use the syntax that means any character but new lines.